Finally, in this video, we will learn how to use the chain rule, which will allow us to compute derivatives of very complicated functions as long as we can write them as compositions of simpler ones. The chain rule is the following formula. So, if we have a function which is the composition of two functions, g composed with h, then the derivative of f will be equal to the following. The derivative of g evaluated at h of x times the derivative of h. So to be clear, to find the chain rule, we need the following. We need first to detect that f is the composition of two functions. The second step is to find what is g of x, the derivative of g, and the derivative of h. And finally, we need that the derivative of f will be the derivative of g evaluated at h times the derivative of h. Let's say this with an example. So here we need to find the derivative of f, where f is equal to the square root of x cubed minus 2. So maybe let's write down the formula of the chain rule. So we need to find g and h in this situation. That is why we reviewed in the past how to decompose a function into simpler functions. So in this case, f of x, which is equal to square root of x cubed minus 2, can be written as using the following functions. So g of x will be square root of x, h of x will be x cubed minus 2, and then f of x will be equal to g composed with h. The next step is to find what is the derivative of g, but this is the power formula. So we will have that this is 1/2 x to the minus 1/2, and the derivative of h of x is 3x squared. And now the final step is to put all together with the formula up here. So we need to evaluate the derivative of g with h of x, then multiply by the derivative of h. So the derivative of f will be equal to 1/2 x cubed minus 2 to the 1/2. So remember here, we're evaluating g prime of x with h, which is x cubed minus 2. And that multiplied by the derivative of the inside function, h. So that is how you use the chain rule to find derivatives of more complicated functions. Let's do another one now. In this case, we have that our function is x squared plus x to the power of 7. So again, maybe let's write down again the chain rule. So remember, the first step is always to try to find what is g and what is h in our situation. So we have that f of x is x squared plus x to the power 7. So in this case, we can write this with g as x to the 7 and h as x squared plus x. So this gives us that f of x is equal to g composed with h. Now remember, the second step is to find the derivatives of these functions. So the derivative of g is 7 times x to the 6, and the derivative of h is 2x plus 1. This is simply using the formulas from the previous videos. And now finally, we put all the pieces together given by the chain rule. So the first one will be g prime of x evaluated at h. So it's the derivative of g evaluated at h, which is 7 times x squared plus x to the 6, multiplied by the derivative of h, which in this case is 2x plus 1. This last formula is related to the chain rule when we have the special case that f of x is equal to g of x to the n. So in this case, the chain rule will give us this formula. Let's see why. So if f of x is equal to g of x to a certain power n, then we can break this function into the following. So h of x will be x to the n, and g of x will be itself. So in this case, f of x will be equal to h composed with g. And now using the chain rule, we have that the derivative of f will be equal to the derivative of h, which is n, times g of x to the n minus 1, this is from the derivative of h, times the derivative of the inside function, which in this case is g. So this is how we obtain this formula here. But there's no need to memorize this one if you don't want. As long as you remember the chain rule, you can obtain this formula. So, as a summary of the previous videos, we now have several formulas that allows us to compute derivatives. The first four that I'm mentioning here are somehow more direct or easy to remember. So the derivative of a constant is equal to 0. The derivative of x to the n is n times x to the n minus 1. If I have a constant multiplying my function, then the constant can be taken out when computing the derivative. And finally, if I have a sum or a difference of functions, then its derivative will be the sum or difference of the derivatives. In some more complicated formulas, we find that if we have a product of two functions, the derivative is given by this formula. Remember, the first function times the derivative of the second plus the derivative of the first function times the second. If I have a quotient, then we have this even more complicated formula, but still it has some symmetry. So it's the derivative of the function on top times the derivative on the bottom minus the function on top times the derivative of the function on the bottom divided by the denominator squared. The seventh one is the chain rule, which says that if I have a composition of two functions, then the derivative of f will be the derivative of the outside function evaluated in the inside function times the derivative of the inside function. And as a special case of the chain rule, we have what we call the power rule.